This is the Microsoft Cloud Show, episode 99, where CJ and I are going to talk to Andrew Liu from Microsoft about Azure DocumentDB.
Welcome to the Microsoft Cloud Show, the only place to stay up to date on everything going on in the Microsoft Cloud world, including Windows Azure, Office 365, SharePoint, Exchange, Lync, and related technologies. Just the information, no marketing, no BS. I'm Andrew Connell.
And I'm Chris Johnson.
And we're just two dudes telling you how we see it.
Good day, everybody. This is Andrew, and about a week or so ago, CJ and I sat down and had a conversation with Andrew Liu from Microsoft. Andrew Liu is a program manager over on the Azure DocumentDB team. We talked a lot about DocumentDB and came at it from the approach from people who are traditionally used to working with relational databases, such as SQL Server or Azure SQL Server. So DocumentDB is a NoSQL database and a NoSQL and document-centric database. So we want to give people a good understanding of what these document databases are, what DocumentDB is, when it would be useful, when it would maybe not make sense, and then some typical use cases and challenges that people would have. So fairly lengthy interview, so we're going to go ahead and dive into it, and we'll leave you with it and hope you enjoy this interview. Today, CJ and I are going to talk to Andrew Liu. Andrew Liu is a program manager working on the Azure DocumentDB team with Microsoft. He helps shape and define the vision of that's Microsoft's NoSQL document database service. And in his spare time, he enjoys craft beer, video games, and live music. Wow, man, we got to hang out. That's awesome. Andrew, welcome to the show. How are you doing?
Hey, I'm great. Glad to be here.
This is going to be interesting. We got two Andrews. So CJ, you're going to have fun with this one.
Yeah, I'll be a C and AL. How about that? There we go.
It's a little bit nicer, a little bit more polite than we had a guy on a couple of weeks ago whose initials were BS. And so we were talking about a lot of BS. So I hope that's not this show, though. So, hey, Andrew, the reason we wanted to bring you on was because we wanted to talk about DocumentDB. And like we said in your intro here, this is the Microsoft's NoSQL document database service. And so I thought that, to kind of, before we kind of dive into a bunch of questions and such, as we get a lot of inquiries about this from our listeners, I just want to give you a few minutes to just kind of explain, how would you explain it to people and how would you pitch what is DocumentDB? If I'm a developer and I'm saying, what is this and why should I care about it?
Yeah, sure. So at a high level, DocumentDB is a document database. It's very aptly named. And so what is a document database really? It's a part of the NoSQL family of databases. And so a lot of people kind of use this term NoSQL. It's kind of more of an umbrella term. It really refers to a whole class of databases. It stands for not only SQL, but it includes key value stores, graph stores, document stores. And really, what I mean by document store, it stores JSON. Your data looks like JSON. There's no tables. And what's beautiful about this is that there's absolutely no schema here, or rather, the schema is not enforced by the database. It's really dictated by your application. And so what this brings you is you can really evolve your data model very quickly and iterate over that. You can develop rapidly. So to give you an example, have you ever you built out this beautiful data model for your application on a relational database. You're maybe 2 years now away into your project, and you're adding, yet another feature. And what you find is that your data model you never really designed your data model originally for this, a new feature. Let's say I'm building an e-commerce website, and now I want to expand my e-commerce website out to selling every product out there. I want to compete against, let's say, Amazon and the big guys for as an e-commerce retailer. I sell everything from books to laptops to everything. And the thing is, I started off with just a small little products table, and I wanted to query over my new products, like my laptop, my books, over by their author, by the amount of memory a computer has. But really, how much memory does a book have, or who's the author of a laptop? That doesn't make any sense, right? So what you end up doing is you might abstract this out and go, oh, well, I'll have a table for each product type. But then you end up with a bunch of product type tables. So that's not going to work. So then you end up going, well, what if I made a product table and then a product attributes table? And I'll just join them. And in the product attributes table, I'll just say, oh, the key will be, the product attribute will be author. And for this book, it'll be let's say I'm selling Harry Potter's books and the author is J.K. Rowling. But as these two tables grow, they get really, really large. And when you do a join, that's basically a cross product between two tables. So now you're performing a cross product between two really large tables, and things kind of start slowing to a crawl. And you're going, gee, like, how do I handle this? And so this is where kind of document databases really shine, is when you have this kind of heterogeneous workload. Since the database is agnostic to the schema, like it's really dictated by your application, you can throw like whatever JSON you want. If you want in the JSON, like let's say a JSON property, that's the author, or let's say amount of memory, CPU, you just add it as a property. And then you can query over it. And this is, I think, the beautiful thing about DocumentDB is they also support this automatic indexing. So you're not building all these indices, you're not managing them. You're not saying, hey, I need a secondary index here. I don't have to do any of this, schema transformations where I have to do like, oh, I need to do an alter tables and I made a migration script. And now I'm kind of nervous, like whether this migration script's, going to actually work out for me. So you don't have to deal with any of that. And that's what I think is really cool.
So as a developer, we've all used relational databases for decades, right? What do you think the biggest sort of theoretical change for a dev looking at something like DocumentDB from a application design point of view? What do you think the first thing they're going to need to think about? Because for me, for years people have built in almost like business logic into their table structure and schema in the database, right? So like this property is required, it's got to be an integer, or it's got to be a string of a particular length or something like that. This seems like the sort of the wild west of do whatever you want, right? And developers are going to be like probably a little confused about how to build their app differently to take advantage of it. So what do you think some of the fundamental things that they need to think about now that they didn't in the past will be?
Oh, sure. Yeah. The biggest thing I think that's different is now you have the option of denormalizing your data. And you can query over denormalized structures. So instead of having, let's say, normally in a relational database, you would abstract out like each entity type gets its own table, right? And this is called normalizing your data.
Yeah.
And you could denormalize where you can say, like, let's say a nested object as a really long string, like a varchar. Or I think in the new SQL Server, you actually can store JSON as a data type. But the difference is you can now query over denormalized data. So like when you have data that's like hierarchical, let's say I have a product order, and within that I have items. And those items, I really kind of want like kind of a snapshot in time. Like if I update the price tomorrow on the item, I don't want users to be confused and be like, hey, I spent $20 on this book, and now you're selling it for $15, and on my invoice it says $15, but I clearly was charged $20. So you can store these like nested objects. So that's part of the JSON spec, right? You have two new data types. You have objects and you have arrays. And so you can also have nested arrays of objects, which then can contain, let's say more objects. So when you're doing this data modeling, you'll want to think about whether you want to normalize your data or denormalize data. What are the trade-offs? And the thing is, what's kind of cool here is I think a lot of people think it's like one or the other. You actually can take a hybrid approach here. You want me to talk a little bit about, like, I think what the trade-offs are when you would normalize, when you would denormalize?
Oh, yeah. I'd love to hear that.
That sounds really interesting. Yeah.
Okay, sure. And typically, like, when you would want to denormalize is what you're doing here is you're optimizing for reads. And the reason I say that is as a NoSQL database, there are no inter-document joins, meaning I can't have, let's say, one record that has a foreign key to another document and just resolve that in a join. Now, typically what would happen in a NoSQL database is that if you had a normalized data model, you would then do a follow-up query, right? So you would pull down one record, see, I have a reference to another record, so now I'm going to pull down that record. And now you're doing 2 round trips. So what you get with denormalizing is you get to read this, let's say a set of data, let's say a parent object as well as all its children, all back at once. And they're actually all stored right next to each other on disk too. So the database itself isn't doing any kind of subsequent lookup. It's just pulling all of that back. And this works really well when you have like a one-to-few relationship and when the data doesn't change very often, especially those child objects. So when you would normalize is when the data mutates quite a bit or you have a one-to-many relationship. The reason that is you can imagine that if I've denormalized a child across, and I have the same child across many different parents, if I want to do like, let's say an update operation, I'm going to have to fan out that write to many different parents. And as a result, like what you really get for normalizing is you get much better write performance, because now you don't have to fan out your write. You can just write one normalized, child. Like it's one child rather than a child across many different parents. Does that kind of make sense?
Yeah,
it does. I mean, so in that scenario too, that you were just describing, would I have a scenario where, again, I'm going to come at this from a noob approach here, but if I have a scenario where, like taking your example, I have books and I want to have a nice denormalized structure to have a really nice fast reads and stuff on my site showing like a product catalog. If I want to go back and I want to make updates to it, is there a scenario where you would, to still optimize my rights, would I have kind of like two approaches to where one process would do an update to all the rights as like my master, and then I have a separate one that I would have that would be denormalized for all my reads? Would you do something like that, or does that not make sense?
So the way I would handle this is I would look at what my query patterns are and what my write patterns are. And so what I recommend is normally taking kind of this hybrid approach. So you can imagine, let's say if I had orders on my e-commerce website and I had a bunch of child objects, which are like the items, right? I might denormalize the price, because when I update the price, I really don't want it to update on the order. But for things like the title, if I update the title of this item, I might actually want to, I don't want to fan out that right. I want this to be reflected on, let's say, on all of my orders. In that case, I might normalize this. Mm-hmm. And so what you end up is, like, if I wanted to do a quick read on the order document, I can calculate things like price real quick, because in a single, like the order total, like I have a little invoice. I might even have a snapshot of let's say a title that doesn't change very much, and then a description that might mutate. And in the summary in the title, I'll get that back right away on my original document. But if I wanted to drill down on more details on the item, then I might issue another query to get the normalized item document and pull out, all those additional fields or additional details.
I see. So one of the scenarios here that when I was kind of curious about, that someone was asking me about the other day, was that, let's take your books example here. If the way, like, how does the process works? I mean, when you hear DocumentDB, a lot of people think that, there's actually a physical file, there's a document that's sitting on the server somewhere. And so is that document of a book, or is there a books document that contains a huge array of all the books? That's one question. And then the other question to that is, and let's say I want to go through and I wanted to update one of those books. So is the workflow process that I would actually go through with my code is, first I'm going to go back and go get the document that contains the actual book. I'm going to make changes to that actual document. And then do I do an update back to the DocumentDB, or am I actually re-uploading the same document back and letting DocumentDB figure out that, I've already got the same one. This is going to be like a merge or an update to the existing one.
Gotcha. Okay. So first, what is a document? I want to make sure that by document, what I mean is JSON. It's just a JSON object. It's not like a Word document or a PDF. So don't get those confused.
Very good distinction.
I once had a colleague who was giving a talk at a event, and I think he shared a room right after one of the SharePoint presentations. And the attendees who stayed behind to check out, what is this DocumentDB? Oh man, were people confused?
Yeah.
We get that. So CJ and I are both old SharePoint people. So I can totally respect that. I can totally understand where that comes from.
Okay. So what's kind of cool about JSON is you should think of it, you have basically a bunch of JSON properties. Let's say they're key, and then you have a colon and then a value, right? And the value can be a string, it can be a numeric, it can be another object, it can be an array, it can be whatever. What's interesting about this is JSON is self-describing. It actually gives you the schema right there. It says the name is this, or this property has this value. And because you know what the properties are ahead of time, what we can do is, behind the scenes, you should think about documents, or rather JSON. It gets stored as a tree, where we build a tree where you have, let's say, a root node. And each of those child nodes are going to be a property, the key of the property. And I'm going to then have children underneath those nodes, and those will either be the value of those key, or if that was an object, I will break it up and have the the keys of that child object. So basically, I've now broken this as JSON as a tree. And the reason why we're able to do automatic indexing over these documents is because you have now described the schema, and I've broken up into this tree form. And now if I merge those trees across many different documents, and then at the very bottom at the leaf nodes, I point back to, let's say, the document itself, or rather the data itself, then I can now do very fast lookups, right? I just navigate down this tree. So let's say I have, millions of documents, and only, let's say, 1,000 of them have this property. So I go from the root node down to the next node, which is that property. And then I can build a variety of indexes, rather a range index, which will look more like another tree, or a hash index where you think more, you do a hash lookup. And from there, you can just pick out the value and you have a reference to the document itself, or rather the data itself.
So that's a little bit about how you guys treat the documents and so forth. My understanding is from a developer's standpoint, querying these things looks pretty familiar to what we're used to in T-SQL, right?
Yes. So a lot of the things that you learned as a relational developer actually will carry over.
Is that unique to Azure DocumentDB, or is this a NoSQL thing in general?
No, this is absolutely unique to DocumentDB.
Gotcha.
So what I've found is a lot of document databases out there, they come up with their own query language, and you end up having this learning curve of having to, ramp up and learn a completely different query language. And then when you're onboarding new members onto your development team, you're going, oh man, I basically have to teach this every single time because no one's going to come with any context of how do I query over this data. What's kind of cool about DocumentDB is we decided to use SQL as our query grammar. And so we tried to stick to the ANSI SQL spec as much as we could. Obviously, we had to deviate a little bit because we are a document store. And so some of the things that are a little bit different, like the main thing that's different is the join keyword. The join keyword no longer does an inter-document join, but rather it does an intra-document join. That's a self-join. And where that's useful is because you can now denormalize data and you want to query across, let's say, a nested array, then you can join elements onto the array and then do lookups on those objects without having to know what index position it is.
Gotcha.
Yeah, the query stuff I was looking at, there's a really good demo site. It looks like you guys own this. The documentdb.com/SQL/demo. It's got some good examples here where it shows like what the syntax looks like. And you're right, it looks and feels very much like T-SQL. In fact, I guess I'm just looking at the select syntax and it looks identical to it. The join by, it looks fairly familiar too. I mean, all of this looks very intuitive. Now, did I see something recent where you guys actually introduced another query language just recently?
Oh, yes. So what we found is one platform that works really well with document databases in JSON, and I mean, JSON stands for JavaScript Object Notation, is writing JavaScript, right? JavaScript really interacts with this quite naturally. You don't have to do any kind of translation of here's some JSON that I've serialized, and now I need to convert it back to an object. Like JSON actually just treats that as, no, I understand what this is. So to kind of cater towards JavaScript developers, we also created this JavaScript language integrated query. And so you can use functional programming idioms or the keywords that you're kind of already familiar with JavaScript, like array built-ins. So you can think of a collection in DocumentDB is just a group of documents, right? This is a partition where you store all of your documents, and it's the boundary for where you can perform queries and transactions.
So you'd call that like a database.
So you think of it as a database. And I would treat it more like a database than a table because collections don't enforce schema. And therefore, you can mix entity types within the same collection. And the benefit over that is you get to query across many different entity types all at once. So if you wanted to, let's say, query by product ID, if you wanted to, you could leave out, let's say, and type equals. What I'd recommend generally to separate out different entity types is to add a entity type attribute to your JSON. So then you can query on a specific type using and, or you could just query across all of the entity types that are relevant to you, all in a single query. And going back to JavaScript language integrated queries is within these collections, you can query over using a functional programming idioms like filter, map. So instead of doing a select clause, you would do a map. instead of a where clause, you do a filter. And what's kind of cool is you can write this in actual JavaScript. You're not building kind of a SQL string and sending the SQL string over a wire.
That's very much like using, if I was in the C# space with SQL, with SQL Server, that's very much like the language integrated query, a link that we're used to.
Yes, yeah.
Yeah, the syntax for that looks pretty similar to that. I mean, it is, I can see that definitely the benefit, instead of building up a string and then sending it across the wire, you actually get potentially like IntelliSense or auto completion, some checking and stuff with the language integrated query, with the JavaScript language integrated query. If it would it be correct to say that if I wanted to enforce some sort of a schema, so like when I'm developing, I'm working with some data coming from DocumentDB. If I reference a property that doesn't exist, it's not going to throw an error. It just gives me a null in that value. Is that correct? Like if I go for documents, and if I'm going for let's say I'm going for books, and in that books I say something like engine type, and I'm trying to pull some property that doesn't exist on a book, it exists on a car.
Yeah.
And I haven't put that as part of the document. Does that throw an error when I'm doing that query, like it would if I was trying to select a non-existent field in SQL Server? Or what does DocumentDB do when actually pull data back from a property that doesn't exist?
What I'll do is, it depends whether this is in the projection, which is the select clause, or if it's in the filter, which is the where clause, right? So in a where clause, if I were to look at engine type, I'm only going to find documents that have an engine type. This way you can go, oh, I'm really looking for a car. So like, let's ignore all these books. Like that's not relevant to me right now. And a projection, what that's going to do is it's going to pull out that value based on that filter. So if you're selecting everything and you want the engine type, like you might have books in your data set, and as a result, you're going to get, a null value. So it depends on where you're making that reference.
I see. That makes sense. If I wanted to enforce a schema as the developer, if I want to enforce a schema that I'm actually working with, would you say like a good option that that's where something like, say, a TypeScript, and using like interfaces with TypeScript that would be able to enforce like a specific object type that I want to work with? Is that kind of a direction that someone would want to go in?
At a high level, like one of our goals is, rather than having your database and application kind of enforce a schema on you, we really want you to just make that change in one place rather than two places. So your application is where you would dictate that.
Okay.
But if you really wanted to enforce this on the database side, we do support the concept of both store procedures and triggers. Now, the triggers are going to work a little differently in that because we're mixing entity types in a collection, we want you to invoke the trigger as opposed to us automatically running it on every single document ingested.
I see.
But within that trigger, what you can do is you can do some validation. So you can say like, oh, I want to enforce, that your document at a minimum has this set of properties, and if it doesn't, I'm going to reject it. So in the trigger, you can write that kind of business logic.
Okay, that's where I was trying to go with that. That makes a lot more sense.
So I've got a quick question about upgrade and iterations on your application and things. And we're all devs here, right? So we can bag on the IT pro guys for a while. But to me, this seems like a good way that IT pros get out of having to deal with upgrades to or version to version upgrades of databases behind the scenes, right? Or your SQL guy having to deal with schema changes in production databases and potential data loss concerns, and that stuff's really, really quite hard to master and do really well. So is this just a way of saying, hey, look, like all of the rules and everything is taken care of in the app, and really the back end is just a bit bucket, right? And it doesn't have to, you don't really have to ever upgrade your bit bucket. You upgrade your app and it does all the enforcement of schema, or what schema you have, or how little you have. All of the rendering of the UI, all of the business rules and logic, all of that sort of stuff. It sounds like the IT pros are going to have an easier job because, or at least the SQL DBAs are going to have an easier job because they're not going to have these developers that sort of write these really hokey upgrade scripts for SQL and end up losing production data.
Right. So this is one of the things that I love most about it, because I do a lot of like hobby apps in my spare time. And really, like for a hobby app, I can't afford to hire a DBA like just for me, right? So what's kind of cool is like, yeah, this is a database as a service. That means that uptime is taken care of by DocumentDB. Like you don't have to worry about it yourself. Hell, if you're a small team of developers at a small company, you don't have to worry about getting paged because your database is having issues. Like someone at DocumentDB will get paged and their night will be kind of ruined, but you get to keep sleeping. In terms of operating system updates, database updates, I really hate having to spend all my time, there's a new security critical patch I need to install, and there's some new software updates. I'm spending all my time doing these updates and making sure that happens reliably and that I maintain uptime. You know what? Let's get rid of all of that. Let's have DocumentDB take care of that. And as new features come in, as updates come in, because it's a service, it automatically just appears on your database account. You get access to that for free, and you can just keep writing your code, keep building your app, and ignore all of the operational stuff.
So from an app upgrade point of view, though, I can imagine a scenario where, say, you've got, let's go back to our sales system, or our online shop or whatever we had, right? So say you end up having books, you're selling books, and there's different genres for the books, right? What happens if you start with your genre being a string and you want to move to your genre being some sort of lookup or something like that, rather than being sort of free text? So instead of having to, in the traditional relational database world, you'd have to go through and you'd have to go and add a genre table, and then you'd have to go modify your books table or your products table or whatever it happens to be, and add a genre column or change the current genre column, and then do a whole bunch of application processing to take the current data and then move it into this new sort of many-to-one lookup style system. So how would a developer deal with that in a NoSQL world? How would you end up dealing with that sort of scenario, or in a DocumentDB world, how would you end up dealing with that scenario?
If this was simply adding a property, or I only want to make this change for new documents, new data coming in, that's just cool. Since the database itself doesn't really care, you can just start throwing a new formatted JSON, and it'll just take it and you can query over it. Yeah. And it gets automatically indexed. It just works. Now, if you wanted to make an update on all existing data, let's say you wanted to do, I don't want this lookup to be by a string anymore. I want to convert all of my existing documents also to use, let's say, some kind of new format. Let's say I have a nested object. In that case, you're still going to have to write a migration script. And the way I'd go about this is, what's cool about stored procedures is you write basically a body of JavaScript. And we chose JavaScript as kind of our version of T-SQL. Because we found that JavaScript, it works well with JSON, and it's very expressive. And what's nice about running a stored procedure is you got this logic of code, and you can do a sequence of operations or a batch of operations all local to the storage partition. It's very, very fast. So if you have, let's say, a large list of operations, like a bunch of updates, if you were to do it on the application server, what will happen is you're going to have these really long network requests, and network requests are always going to be your bottleneck, because DocumentDB itself, reads are going to take less than 10 milliseconds on the storage partition, and writes will take maybe just north of 10 milliseconds. It's rather fast. You're really bottlenecked by the network latency. For a storage procedure, what you can do is you can write, let's say, a bulk update, and that'll run local to the storage partition, and it'll perform all of that sequence of updates, really quick in a single network request.
So instead of saying have a SQL Server, upgrade script, now we're going to have a JavaScript upgrade script that we go run as through the stored procedure mechanism in the cloud.
Yeah.
Gotcha.
Well, it sounds a lot easier than it would be for a more relational model, because there's more kind of defensive coding you have to write and stuff like that, a lot more of the planning and stuff, where with DocumentDB, you can just kind of make the change and just keep running, and then kind of have a retroactive thing that just says, let me just go update the data. It's not that I'm updating the schema. I just need to update the data to match what the code is going to be expecting for the new stuff. Let me ask you a question then about I guess two questions about one from a meta question and then one for more on developers. From a meta question, where would you see that when does something like DocumentDB when would you say that it does make sense? When do you say that it does not make sense? And I'm a developer, and I fully get that whole thing. With SharePoint deployments I've done for so many years, it's like, when does SharePoint make sense and when does it not make sense? I'm like, oh God, I could go on this forever. But when you say, like, what is the right scenario that you would say that would be like, when you hear someone say, I'm building this kind of an application, you're like, yeah, DocumentDB doesn't make sense to build, like, Amazon.com. But if I'm going to be building like a CRM based system for my organization, is DocumentDB something that we should definitely take into we should consider? Or am I looking at this in the wrong way? Should I just be saying this is really more of a developer style thing and not so much an application should dictate what kind of a data store that we should be looking at?
The way I view databases is, 10 years ago, when everyone was working on relational databases, you kind of treated the relational database as a hammer, and everything looks like a nail, and it's your general purpose go-to database. Today, I think we're kind of in a database renaissance, and you have all sorts of new database products coming out. You have key value stores, you have relational stores, you have document stores. They all each have their own unique strengths and weaknesses. And so now you kind of get the option of picking the right tool for the right job. So if you have a screw, like before you had a nail and you could really kind of force the screw into like this piece of wood and you can just hammer it in, really like a screwdriver or a drill would have made so much more sense. Mm-hmm. So where I think DocumentDB kind of fits in is whenever your data model is evolving very rapidly and you don't want all this friction writing migration scripts, it really allows flexible schema. And not only that, but it allows you to query off of, everything's automatically indexed and you can query off of any property. So it allows you to move very fast. I see relational databases as something that's very good for highly relational data. You can normalize your data and do joins across, arbitrary tables. You can just add a foreign key, and wherever it makes sense, you can create a relationship. That is I think where DocumentDB does not do very well, because you lose joins and you would have to perform follow-up queries. And then key value stores. So Azure has this other NoSQL database called Azure Tables, and that's a key value store. Mm-hmm. And I find the benefits of a key value store is you can store data really, really cheap. The thing is dirt cheap. It's awesome. And it scales quite well. The only drawback is, since it's a key value store, you can only query by a primary key. So like, for instance, if I was making my e-commerce website and I was storing, let's say, a bunch of orders, and I make the order ID the key, I can only ever query by the order ID. I wouldn't be able to query by customer, query by, it has this product. And so depending on your query patterns, like that's what I would look at. Like if you're only ever querying by a key, like please use a key value store. It's purpose built for that. If you have highly relational data and your data model is, very set in stone, like there's no uncertainty, you're not going to iterate on top of it. Like a relational database, I think is still an awesome fit. But if you wanted this blend of like flexible schemas and queryability, DocumentDB is kind of like that nice middle ground.
So how about this then? Tell me if I'm getting this right. Let's say I'm going to build something like a CRM system, right? And maybe within the application that I'm building, the bulk of the application logic that's going to be done and the storage of it is all going to be done using something like, say, DocumentDB. But when I want to be able to do any kind of like a trace and logging all of the audit activity that happened inside of that application, that's where a key value store or like the table storage is going to make sense, because I could have a primary partition key be, say, the customer. I could have a secondary partition key. I forget what the exact terminology is, but I know there's like a primary and a secondary. The primary would be the customer ID, and then the secondary would be like the action that happened or something like that. But I would never be looking up like based, the specific audit like text. I'm looking at, let me see an audit history based on that person and maybe the type of an action that happened. And then if I need to do any kind of analysis or any kind of like analytics on the all the customers, that's where maybe I have another process that's maybe either loading, doing like an ETL kind of a process into a relational model so that I can do more like business intelligence on the CRM system. Is that a fair way to kind of like characterize these different models?
Yes. So what you're also referring to is, you have a partition key and a row key.
Row key, that's it.
And that is the primary key for tables. Yeah, you don't get secondary indices, which I think is when you would want to use another product. I like your example. Like the audit trail goes into tables, and When you want to perform analytics, you can use like, let's say, HD Insight, run a Hadoop job, pump that into, let's say, your SQL data mart. And then if you have some mission critical logging, like let's say as requests come in, you want to really reduce that time to mitigate an incident. So whenever you have, like, let's say, a log that you need to be able to query over very quickly, and you can't afford to wait for a Hadoop job to run, put that in DocumentDB. And then you can do lookups like, oh, I know that I'm getting fatals or errors on this request ID. And or I know it's associated with this customer ID. I can do kind of these arbitrary lookups, store this in DocumentDB. It doesn't care about the schema. So you're not actually writing like migration scripts over your log database, which would be kind of painful, to be honest.
Oh, yeah.
Yeah, you want this to be low maintenance. So you just dump that in DocumentDB and you can query over like any arbitrary attribute.
Awesome. So one other question then about, let's say I'm a developer and I want to get started with this. Now my understanding is that the entry point is that you're essentially buying is $25 a month is the entry point. That's even like just if a developer wants to go build a sample app. There's no free tier to this. It's $25 to get in, and that's for one collection for 1 month. Is that correct?
Yes. So it's billed hourly, so it comes out to I think like 4 cents an hour. But yeah, what you're buying is that comes out to like $25 a month. You get 10 gigabytes of space, and you get 250 request units. So I'll talk a little bit about request units and what those are. Those are kind of like a logical or virtual currency for measuring throughput. You can think of this as if I was standing up a database on my server and I knew that I needed to support, let's say, 1,000 requests per second. And right now, today, I don't hit that. Well, I can buy some more CPU. I can buy some more RAM. I can throw hardware at this, right? But let's say I need to, today I can hit 600 requests per second, and I need 400 more requests per second. How much RAM should I buy? How much CPU should I buy? Like, I don't have a clue, right? Like, there's no like, 2 gigabytes will get me this many requests per second. So this makes,
keep throwing hardware at the problem till it goes away.
Now I got to talk to those IT pros again.
Yeah.
It makes it really hard to predict, what you need to get to scale out, to that point, right? So what we did was we abstracted out, CPU, IO, memory into a logical unit called a request unit. And what you can do is if you issue a query and today it costs, let's say, 2 request units, right? And I know I need to support 10 of these concurrently. Well, I just multiply by 10, that's 20. Do I have enough request units to support 20 request units per second? Well, the different performance tier range from 250 request units per second all the way to 2,500 request units per second. So I know, okay, yeah, that's great. If I need, let's say now 10,000 request units per second, it's very predictable. I just need 4 collections, 4 S3 collections. Like you have a very concrete way of, you can just predictably say like, oh, this is the number of collections I'll need. And so that'll be the pattern also if you want to store, let's say, more than 10 gigabytes or have more than 2,500 request units per second, as you would scale out through collections. And we really want you to scale out, not scale up. So scaling up is just throwing hardware at this problem. And well, when you're in the cloud, that you don't really get to dictate the hardware anymore, right? So when you're doing cloud development, what you want to think about is you want to scale out. So what I'll do is I'll partition my data in such a way, like let's say if I had 100 gigabytes that I need to store in DocumentDB, and I'm basically building a multi-tenant application, like some multi-tenant SaaS application. That's why I need so much storage. What I can end up doing is I can go, oh, well, I'll take the customer ID or the tenant ID and I'll do a hash partition. Basically, I will take the tenant ID, run it through a hashing mechanism that spits out a number, let's say 0 through 10, corresponding to collections 0 through 10, and then I will route that query to the right collection. And in fact, we actually make this easy for you. In our SDK, we have this thing called a partition resolver, where you just say, oh, I want either a range or a hash partition on these attributes, and the SDK itself will automatically resolve to the collection or a partition.
Oh, that's pretty cool. Yeah, and I see that the scaling thing from going from 250 request units per second up to 2,500. I mean, that's a tenfold increase, but the price only goes up 4 times. So it's like 250 request units per second is $25 a month, whereas if you go all the way up to 2,500 request units per second, that's $100 a month. So you get obviously the scale works nice as far from the dollar perspective. And then you're saying then you would actually, with each one of these different units, you're getting a 10 gigabyte collection. And if you have more than that, then you should look to see how can you actually partition your data out into up to 10 gigabit containers.
Yeah.
Okay, I see.
Gigabyte, not bit.
Oh yeah, gigabyte. Yeah, a little bit bigger. We're going the wrong direction with the cloud.
And you originally mentioned free tier. We don't have a free tier today. So my recommendation is if you have something like an MSDN subscription, you get Azure credits. I think you get something like $150 a month in Azure credit. You can use that. We do have a free trial on Azure where you can sign up for 1 month free, and I think you get like $200 worth of credits. Or I'll tell you another secret way of going about this. Message me. I love to help people. I mean, if you want a free trial, like I can create I'm happy to create a collection on my own account and give it to you for, let's say, 1 month for you to try it out. That way, like you don't have to pull out your wallet. The way you do this is email me. My work email is andrl@microsoft.com, or you can tweet me. I'm pretty active on Twitter. My Twitter screen name is ALIUY8. Yeah, tweet me, DM me, and I'll hook you up.
Hey, I also noticed I was playing around on the DocumentDB website, and there's like a little query playground as well. So if you just want to kick the tires and try a few different queries, it looks like you got a sample data set up there and a little sort of sandbox you can tool around with to try some queries.
Oh, yeah.
Looks
I
nice.
highly recommend that. That'll give you, you don't even have to read docs then. You can just go and say, oh, here's some example queries. Here's an example data set. I can play around with it, change the query a little bit, see what happens.
If you're an old T-SQL guy, then things looking awfully familiar.
And the URL for that, again, for listeners is documentdb.com/SQL/demo.
Nice.
We move fast as a service. I think since we released about a year ago, we've added order by support, geospatial indexing, ID-based routing, a new JavaScript language integrated query, online re-indexing, like a bunch of integration with Data Factory, HD Insight. We made a data migration tool for migrating data very easily. Basically, we move very fast as a service. So, follow us. You can follow us on Twitter. We also have a team Twitter account, which is @DocumentDB. So if you want to stay up to date on what we're up to, check that out, or go to the Azure blog. We normally write a little blog post each time we have something interesting to throw out there into the world. Yeah,
absolutely. This is extremely timely for me as I'm making some technical decisions in what I'm working on, and so half of my questions were pretty much aimed for my benefit only. Nice.
Thanks for having me. And if you ever have any follow-up questions, feel free to contact me. I love answering questions. Yeah.
All right. Cheers.
See ya.
If you have a question for us, go to microsoftcloudshow.com/questions, where you can submit it as text or record it as a WAV or an MP3 file and provide a link so that we can play your question on the show. Our theme music is an excerpt from Evaporated Eric by Monk Turner, used under Creative Commons. You can subscribe to us in iTunes by searching for the Microsoft Cloud Show or via RSS at microsoftcloudshow.com, where you'll also find a full transcript and show notes of each episode. You can find us on Facebook searching for the Microsoft Cloud Show or on Twitter @MS Cloud Show. Thanks for listening. We'll see you next time.